Hello to you. I'm Jessie Johnson. This is Earth Navy Tracking 2-inch pencil beams and elevation drop. The Earth, being ball-shaped, makes sense from a certain viewpoint as long as it do not spin, which is centripetal force impossible. Also, since the Sun, by angle of elevation, is 1,651.29 miles away from Earth, when circling the equator, then you have to explain how this can be around a ball globe Earth. So, to find the elevation drops of a ball Earth using a circle, how to determine if the Earth is curved, circular, or a plane flat surface was done or made. First, I drew a circle, not a regular circle, but a big-ass circle, 16 feet, 8 inches in radius. Not the whole circle, but about 45 inches of it. That's all that was needed. We'll start with A. The scale I used was 1/2 inch equals 10 miles, 5 inches equals 100 miles, 50 inches equals 1,000 miles, and 4 times 50 inches equals 4,000 miles, or 200 inches. And 3/64 of an inch equaled 1 mile, such that at 500 miles out distance, there is a 41-mile elevation drop. At 250 miles, half of 500, at 250 miles, it's a 13-mile elevation drop approximately. At 125 miles is a 4.5 mile elevation drop approximately again. At 62.5 miles, it's a 7,392 feet to 2-mile elevation drop approximately. And at 31 miles, it's a 2,464 feet to a 1-mile elevation drop approximately. The circle I drew represents an Earth 24,901 miles in circumference and 3,965 miles in radius. We'll go to C. That was B. We'll go to C. This is an illustration of that. Hold on, please. Now, to continue. This here represents the Earth, this circular line, and this here, this straight line right here, is a tangent to the circle. A tangent is a straight line which touches a circular line at one point and one point only. This line represents 500 miles. 500 miles, 250 miles, 125 miles, 75 miles, 62.5 miles, and 31 miles. At 500 miles, the elevation drop is 41 miles. At 250 miles, this here is a chord line. This line right here, this line, a chord line connects 2 points, A and B, 2 points of a circle from the inside of the circle. And at 250 miles, there is a bulge of 20 to 23 miles, a bulge of 20 to 23 miles. At 75 miles, at 31 miles, at 31 miles, there is a 2,464 to 1 mile elevation drop. This elevation drop at 31 miles produces right here, produces 500 feet to 1,100 feet bulge of water. And here is the radius line. Now, to continue, Now, a chord is of basic geometry and is a straight line connecting 2 points of the circle from inside the circle, and this was to measure the water bulge at 31 miles and 250 miles. The water bulge was at 31 miles, that is 500 feet to 1,100 feet. And at 500 miles, the water bulge is 20 to 23 miles in bulging. This is created by the circularity of the Earth. Now, all of this was done to state that the workings of a 2-inch pencil beam, which is a form of Navy tracking that the Navy uses to track ships and vessels, enemy or friendly. Now, a 2-inch pencil beam has almost or very little fanning out at long distances. It is one of the most narrow beam tracking systems there is. As the name itself implies and shows, 2-inch pencil beam. Now, we'll go to D as in Daniel. D, for this illustration, because the beam is so narrow, it must be swept side to side. I'll show you the illustration in a second. It must be swept from side to side, parallel or extremely close to parallel over the surface of the water. If the beam goes into the water will absorb the beam's energy, making it useless. The beam cannot go through 60 to 100 miles of water, which is 500 feet to 1,100 feet thick. The ocean would have a flat water surface for the 2-inch pencil beam to work, and not a curved circular surface. A 2-inch pencil beam can detect a ship 50 to 125 miles in distance from the Navy ship on the surface, only if that surface is planar or flat. Excuse me. But to continue, the beam does not bend 500 feet to 1,100 feet over the 50 to 125 mile distance to detect the ship. The tracking beam stays straight as a straight line, and the beam is used as a form of water surveying to tell if Earth's surface is flat or curved. Now, if you have a computer, you will be able to do this with much more precision. Now, to show you an illustration of what I just stated, hold on, please. Now, to continue, as I stated before, this here, This here is the Navy ship. This here is the 2-inch pencil beam system, and here is a beam with this dotted line, a beam, 2-inch pencil beam. This here round line is the Earth, and between this point A and that point B is a straight line called a chord line, and when this is measured, it creates a bulge because of the circularity of the Earth, and that bulge at 75 miles is between 500 feet and 1,100 feet thick. That simply means that the beam cannot bend over the water and detect another ship, and it cannot go through between 50 and 125 miles of water because the water would absorb all of its energies. So the only way for a 2-inch pencil beam to work is for it to be a completely flat Earth so it can go straight across. Now, I want to thank everyone for listening and watching, and share this video, and come back again. We'll meet on the next video, and have a very good day.